Welcome to Pomodoro Joe for Tuesday, August 1st, 2023. Today we're doing LeetCode problem 77, combinations. This is a medium problem. Given two integers, n and k, return all possible combinations of k numbers chosen from the range 1 to n inclusive. You may return the answer in any order. All right, so there's a couple different ways we can do this. I think I'll start with the recursive function, and then I'll show you a shortcut. So let's jump into this. All right. Put 25 minutes on the Pomodoro timer, and we will get started. So the plan here is to take every number between some start, in this case 1 and n. That will be our prefix, or that will be the element that we start our array with. Grab that element, and then we can recurse on the remainder of the numbers from that number forward until we have a length k array. Okay, so let's do this here. So we're going to define combine recurse. This is our recursive function. And we will basically be reducing our k for every call to our recursive function. So we'll have some remaining k. All right, so first let's do our base case. If k is 0, or remaining k is 0, then we return. All right, and now we need to return a list, and this is a list of lists. So we'll return a list, and it will have an empty list as its one element. So we'll return our list of lists. We're out of remaining numbers that we can add, so we just return an empty list, or a list of empty lists. All right, next we'll have some result. Now for this, we're going to go through every n, or every number in n, make that the beginning of our list, and then recurse on the remaining k numbers. So for every number, what do we call this? I. So for any number I in range, we're going to go from 1 to n plus 1 because this is inclusive. So we need to add 1 to n because range is exclusive. So we'll go for every I in range from 1 to n plus 1. All right, so for this, we'll have some prefix. So this is the start of our array, and that's just going to be this integer. Next, we need to go through all the remaining numbers that we'll add to this prefix to create combinations of k numbers. All right, so for this, we'll need to do our recursive call. So let's call these our suffixes, I guess. So these, we have our prefix, this is the start of our list. So we'll have the suffix, which will be the end of the list, and we'll have a bunch of different suffixes. So that's going to be our recursive call to combine recurse here. And we need to reduce our k, so we have remaining k minus 1. All right, now for every suffix, we need to append that to our prefix, and that creates one result. So we'll do that here. For suffix, in suffixes. Now this is a little bit tricky because we're dealing with lists, and lists are reference values, so I kind of need to make copies of this list. So one quick way to do that, this is our option here. We'll just create an empty list, and then we'll append our prefix and our suffix to that empty list. That will make a copy for us, so we don't have to actually do the copy call. All right, so now we'll append our prefix to our suffix, create a copy, store that in the option, and then we just put this option into our result. All right, so after we get through all that, we can return our result. Now one problem with this is we're not accounting for duplicates. So if we go, let's say 1, 2, 3, 4, 5, and then we do our remaining 1, 2, 3, 4, 5, we might end up with a 1 and a 1 and a 2 and a 2. So we don't want to go through all of the numbers every time we recurse. We actually want to start at a number that's greater than our current index, our current number I. So this will need to actually have some start index. So I'll just call it start. So we'll pass in the start. What number do we want to start on? Then instead of starting at 1 every time, we'll start at our start number. This will eliminate all the duplicates of having, say, the same number twice, or having 1 and 2, and then 2 and 1. Now we'll have 1 and 2, but then we'll just have 2 and 3. So it won't go backwards. All right, so that means that this start here has to be I plus 1. All right, so we're looking forward only. We're never looking backward. And then finally, we do need to make our initial call. So we can just return. This will be combined recurse, and we do need to pass in 1 for our starting value and our initial k, which is just k. All right, so this should do it. So we have our combined recurse. So we have our start index or our start value. Where do we start? And how many k or how many numbers do we have left? If we're out of numbers, we'll just return an empty list or an empty list of empty list. Next, our result. This will store all of the lists that we put together from taking our current prefix, which is just this number. So we'll go for every number in range from the start to n plus 1. Well, to n, but we use n plus 1 in this range because this is non-inclusive. So we'll grab that number, put it into some list. Then we'll find all of the different ways we can end this list. We do that by calling the combined recurse on I plus 1 with the remaining k minus 1. So we can reduce the remaining k by 1 because we're using this 1, and we're only moving forward in our numbers. We're not going to look back. That will help us eliminate any duplicates. Then for every suffix we get back, we just add our prefix to that suffix and put that into our result. All right, let's try this. So this works. Let's see if we pass. And we pass. And we do okay. We beat 77% for runtime, and looks like a very low number, 6% from memory, so not great. We could try, let's go back here. We can cache. I don't think this is actually going to help us at all, but we could try this. Oh, that helps us a huge amount. Now we're up to 97% for runtime and 6% for memory, so that's a huge win. Wow, I did not expect that. Excellent. All right, jump back here really quick. Couple things. What if we don't use this? What if we just do prefix plus our suffix? Will this still work? Let's find out. Looks like it does. So in this case, it still works. And we actually start beating 99% for runtime. Wow. 99.8% for runtime and 6% for memory. So that does still work. Awesome. All right, is there anything else we can do? I'd really like to get better in memory, but I think it's because we're using lists. If we converted this to using tuples, we could probably do better in memory, but then we might pay the price in our runtime. Anyway, I think that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code. I'm jumping back in here because I totally forgot to show you that shortcut I mentioned. So the shortcut probably will not be as fast as 99%, but let's just do this. So Python does have in the itertools library, a function just called combinations. And you give it essentially your iterable, and you give it the number of chosen values. So in this case, k. So we could just return combinations of, now we do need to do range 1 n plus 1. So that's our iterable, and then k. So this is our shortcut. Let's see if that works. All right, and that does pass, and it does actually better than the others. I was surprised. I didn't think I could beat the 99%, but that beats 100% for runtime and 98% for memory. So, okay, that's the winner right there. Okay, well, I hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.